vectors பத்தி பார்க்க போறோம். Okay, so that is our next chapter as per our book. So இப்போ what is a vector? Vector something that has got magnitude and direction. Okay, contrast this with scalar. Scalar is just a quantity, it has just got magnitude, it doesn't have a direction, whereas vector is something like a velocity, which means you go in a particular direction, you go north for 15 kilometers. That is called displacement. Okay, if you say you move in a particular direction so much of distance, we call it as displacement. So displacement அப்படிங்கிறது ஒரு வெக்டார் குவாண்டிட்டி. அதே மாதிரி velocity, acceleration, இதெல்லாமே வெக்டார் குவாண்டிட்டி. So the only thing is vector must have a direction and magnitude. Okay. So now that we have this digital pen, we can make use of it to explain it. Right. So what is a vector? It is something like this. Okay. So it has got a direction, it has got a magnitude. Okay. Okay. So so you can see that it is something like a segment of a line. Okay, line segment of a segment of a line. Line is infinite, right? Goes in either directions infinitely. Whereas a line segment is a portion of a line. It has also got direction. So a line segment can have two directions. So we can put the arrow either this way or that way. Yeah. So but one of them only is vector, and it has to be clear. It is only in one direction. Okay. So we call it as a directed line segment. So vector's definition is a directed line segment. Okay. Next we come to what is a position vector. Okay. So position vector so if any vector, it has got a, see, you can see this is your, let us say we erase this off. Okay. More line. So first time I'm using this digital pen, so it's a little good of learning for me too. Okay. So this is your directed line. Okay. So this point, this is called initial point. Right? Like I said, it has got a particular magnitude, so it has got a end point. So end point we call it as terminal point. Okay, if position vector we simply move this vector so that the initial point becomes origin. Okay, 0, 0, 0. So it can be in 3 dimensions. Okay, since it's a directed line, it can be in 3 dimensions. So position vector we move the, I'll go to the next page. Move the initial point to origin. 0, 0, 0. Okay. Upper the terminal vector, the terminal point. Okay. So we'll have a coordinate. So that, say, let us say, it can be a comma b comma c. So the a comma b comma c represents a vector. If you say simply a vector ABC, it means okay, it is a vector from 0, 0, 0 to ABC. It's a directed line with a 0, 0, 0 as the initial point and ABC as the terminal point. So that is your position vector. So we simply move. So in a three-dimensional world, okay, there is some line somewhere here. So either a position vector we simply move it as the same, keeping it parallel, and bring the initial point here. Okay. And so this point, the coordinate of the terminal point A, B, C. Okay. This will represent the vector. So okay. So because like I said, vector has got only direction and magnitude. It doesn't have doesn't always have a position. So it can be placed anywhere. And now we conveniently place it so that the initial point is at the origin. And that way we can represent vectors very easily, conveniently, right? So that is the concept of position vector. Okay. So next, what is direction ratio or numbers, and what is direction cosine? Okay. So if vector has got a magnitude and direction, right? Suppose we represent a vector by its coordinate A, B, C, position vector A, B, C. Okay. Let us say vector x. Okay. We represent like this, vector x. Okay. Equal to A, B, C. So it is a position vector with terminal point as A, B, C and initial point as 0, 0, 0. If the magnitude and direction is not very clear from this because it's represented in terms of two coordinates. So what will be the magnitude? Magnitude is then the distance between origin and the point ABC, right? So that will be like we can easily imagine, like in a Pythagoras theorem, the point distance from origin to any point is square root of x square plus y square. Yeah. So in a two coordinate world. So we know that if a point is x comma y, okay. So this is your x and this is your y, and this will be square root of x square plus y square. That is your Pythagoras theorem, right? Y square. Adhe mari we can extend it to three coordinate system. That distance from origin to ABC will become, we call it as r. Okay, that is the distance. Okay. Equal to or magnitude of x. Magnitude of x, vector x, equal to square root of a square plus b square plus c square. Okay. So now we have to find what is the direction. Okay. So Aditya, we represent it in terms of what is called direction cosines. Okay. The distance from origin to that whole length is given by r, which is x bar. Okay. And x coordinate is a, y coordinate is b, and z coordinate is c. Right. Let's go to the next page. The direction of that line can be represented in terms of direction with the x-axis, direction with the y-axis, direction with the z-axis. Clear? So, if suppose there is a vector A, B, C. This is a position vector. Okay? So, if there is a position vector A, B, C, then so we know that its distance is given by root of a square plus b square plus c square, and x coordinate is a, right? So so what is the angle made with the x-axis? So this is your x-axis is a, and the total distance is given by the r, that is root of x square, a square plus b square plus c square, and this is your theta. Okay, so this distance is your a, right? So now you see that cos theta will be a by r, right? So so how can we represent the direction in terms of angle made with the x-axis? equal to a by square root of a square plus b square plus c square. Similarly, the angle made with y-axis will be b by u square plus a square plus b square plus c square. And angle made with the z-axis will be c by a root of a square plus b square plus c square. So with these three, we can uniquely define the direction. If you define the direction with the x-axis, y-axis, and z-axis, then it defines the complete direction set. Right? So we represent these three angles, okay, as, let us say, L equal to cos of angle with x-axis. Similarly, L, M, N, okay, with y-axis, with the z-axis. Okay, so these three are called the direction cosines. So these define the direction of the vector. So is that clear? Anybody has got any questions? Please stop me. Okay. So next concept is types of vectors. Okay. So what are the different types of vectors? Zero vector, abdina, it has got a magnitude of 0. So when something has got a magnitude of 0, the direction doesn't make any sense at all. So that one zero vector. Next, unit vector. Unit vector, the magnitude is 1. Okay. So then that is called unit vector. Hello. Is there any problem? Is it not clear to anybody? Sorry, Samita, you are saying something?
Audible, sir.
Clear. Sorry. Right. So, but co-initial vectors, co-terminal vectors. So, co-initial multiple vectors having the same initial point we call as co-initial vectors. Multiple vectors having the same terminal point we call as co-terminal vectors. Collinear vectors. Collinear vectors, vectors in the same direction. Okay, they are it's parallel. Vectors that are parallel. So parallel can have in both directions. Because there is one vector. So there is one vector like this. There is another vector which is parallel to it. Okay. So it can be in either direction, right? So both of them are parallel now. So in the direction parallel, no, opposite direction parallel. So because they never meet, right? Parallel means those two lines don't meet. So another direction can be plus or minus. So both are collinear. So a vector A is collinear to vector minus A. So that is your collinear. Next, we already talked about equal vectors. Equal, it has to be equal in terms of magnitude as well as direction. Okay, so exact same direction and the same magnitude, right? So they are called equal vectors. Negative vector abdina, so magnitude is same, but only the direction is opposite. So one vector, so in the two vectors, suppose they are having the same magnitude, but the directions are opposite to each other. So one is the negative of the other. So that is the negative. Okay, so whatever we have seen so far, basic things about vector, we'll do some. Let's look at some examples. Okay. No. So there is a problem. Represent graphically a displacement of 40 kilometers, 30 degrees east of north. இதை நம்ம எப்படி போடலாம்? So we have to take the origin. Okay. So the distance is given as 40 kilometers and direction is given as 30 degrees east of north. So we know that this is your north. Yes, I can use this, right? And mark 30 degrees to the east of north. To the east in the side, yeah. So this is your east. So 30 degrees to the north in the direction. So that this is 30 degrees. 30 degrees east of north. And the distance is 40 kilometers. From here you measure 40 kilometers. Okay, suppose the scale is 1. So you know total distance should be 40. So this represents a vector of 40 kilometers. It is unique because it is got a unique magnitude and a unique direction. Okay. This is one example. So let us look at some more basic things. So now classify as scalar or vector. So this I think it's fairly easy I think. So 10 kg, is it a vector?
Scalar, sir.
That's a scalar. That's all. Right. So if you say, yeah, 2 meters northwest.
Vector, sir.
Yeah, that's a vector. 40 degrees centigrade.
Scalar, sir.
It's a scalar. 10 coulomb.
Scalar, sir.
Coulomb is like charge, electric charge, right? So which is like mass. So it doesn't have a direction. Right. Velocity.
Vector, sir.
Vector velocity is a vector, okay, because it has got magnitude and direction. Work done.
Vector.
Sorry.
Vector.
Work done is vector.
Sir, force into distance, sir.
Force into displacement. Okay, it is force into displacement in the direction of the vector. So then, therefore, it becomes like a scalar product of two vectors. So then that becomes a scalar. So work done is a scalar actually. Okay, it's just so many watts, not watts, joules is a energy expended. So that is your work done. It doesn't have a direction. Okay, so it's a scalar. So what about 20 meters per second square?
Scalar, sir.
Scalar.
Vector.
Yeah, this is acceleration, right? Meters per second square is acceleration. So acceleration it has to be in a direction. So it's a vector. No. Now, but answer these questions. Okay. A and minus A. So there are two vectors. Are they collinear?
Yes, sir. True.
True. Now, so two vectors need to be just parallel, to classify as collinear. So A and minus A, they are parallel, right? So therefore they are collinear. Two collinear vectors are always equal in magnitude. Is that true?
False, sir.
That's not true. Correct. Because they are in the same direction, but they need not be equal in magnitude. One can be small and other can be long. Okay. So then still there will be two collinear vectors. Two vectors having the same magnitude are collinear. Is that true?
True, sir.
True. True, sir.
Everybody says true. So there is one vector.
False.
Naveen Vishnu. Okay, so Naveen is right. Because there is one vector. Now if I draw, you will immediately say, okay. So this is one vector with magnitude of 5 units and direction of, in this direction. So there is another vector with same magnitude of 5 units, right? So they are not parallel, right? So two vectors having the same magnitude are not collinear. Okay. So two collinear vectors having same magnitude are equal. Is that true?
False.
False. Why? they are collinear means they are parallel and they are having same magnitude also. So then are they equal or not?
True, sir.
True, sir.
True. Okay. Maybe I confused you. Two collinear vectors. Now, collinear vectors can have either direction, right? So this is, let us say this is one vector. This is one vector and two collinear vectors having the same magnitude. There can be another vector with the same magnitude and collinear, but direction can be opposite. Okay, either collinear vectors having same magnitude because they are parallel, magnitude is same. But are they equal?
No, sir.
No,
No,
because
sir.
A is equal to minus A. It means this is A and this is minus A. They are collinear. See the first problem. A and minus A are collinear, right? So that is true. So these two are collinear, but one is A and another is minus A. So they are not equal, right? They are collinear and same magnitude, but they are not equal because one can be in the opposite direction. You got it?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So now let's get back to our lessons. So we saw this already, right? So, vector. Next we go to some vector manipulations. Okay. So vector components, addition of vectors, multiplication of vector by a scalar, vector joining 2 points, section formula. So these are the things that we're going to see. Okay. So vector components, Abhina, we already saw that, right? So that a vector has got, we represent it in terms of position vector, and the position vector can be represented in terms of x, y, z coordinate, okay, which is the terminal point. Okay. The initial point is 0, 0, 0. Terminal point is x, y, z. Those x, y, z are the three components. Okay. So x component and y component and z component. அப்போ அந்த வெக்டர் நம்ம எப்படி ரெப்ரசென்ட் பண்ணுவோம் அப்படின்னா, it has got the coordinate a, b, c ன்னு வச்சுக்கோங்க. There's a vector a comma b comma c, okay, and that means it is this, right? So if we know that this is the vector whose x coordinate is a, y coordinate is b, and this z coordinate is c, so then we represent this vector x, okay, as a into I, okay. I is the unit vector in the direction of x plus b into j plus c into k. Okay, so this is a way of representing a vector in terms of its components. Okay. Right. So that's about vector components. So addition of vectors. Okay. So how do we add two vectors?
Triangular law of addition method.
Sir, I cap உடைய அந்த magnitude add பண்ணும்.
Yes, yes, that is one way. Yeah, both are correct. Both of you have responded correctly. I'll go to a new page now. Okay. Suppose there is a vector like this and there is another vector like this. So it should have a direction, right? Suppose there are two vectors. Now we want to add the two vectors. அப்ப நம்ம என்ன பண்ணுவோம்? இதோட terminal point A ன்னு வெச்சுப்போம். Sorry, initial point A and இதோட terminal point B ன்னு வெச்சுப்போம். இதோட initial point C and terminal point D ன்னு வெச்சுப்போம். Suppose we want to add these two vectors, what we do is we already saw that okay, vector has got only direction and magnitude, and we can place it wherever we want. Then நம்ம இத கன்வீனியன்ட்டா என்ன பண்ணலாம்? இந்த C வந்து அப்படியே இந்த B க்கு கொண்டு வரணும். So when you bring like this and draw like this, okay, B and C become the same point, D. So this is where AB and this is where CD. So now the addition of two vectors is now given by this vector AD. Okay. So pardon my line which is not very straight and all. Okay. But here this is your triangle law. So you see that the triangle A, B and C, we call it as, let us say, P. A, B and D is a triangle. AB is one vector and DD is another vector. Then the sum of the two vectors is given by A, the third side of the triangle. Okay. Okay. So then other way is, it is equivalent to saying, say suppose point vector AB, okay, is, let us say, in terms of components, we say this is A1 and A1I plus A2J plus A3K and vector another vector CD okay, is A2I plus B1. B3K. Okay. Now this AB plus CD will be A1 plus B1 into I. Update simply we add the I components, we add the J components, we add the K components. So the triangle law and these are equivalent, right? So there are the two ways of vector addition. Next, multiplication of a vector by scalar. Okay. I will go to another page. Now there is a vector A equal to, let us say now I give 2I plus J plus 3K. And we want to multiply this vector by a scalar, let us say, into 5. Okay. Equal to. Simply we multiply the three components by the same scalar. So 2 into 5 and 10, right?
10 I cap.
Yeah.
Plus 5 J cap.
Correct.
Plus the 15 K cap.
Yeah. Alright. So in terms of graphic representation, so this is your vector A. Okay. So 5 times vector A, direction is going to be the same, only the magnitude will become 5 times. That's all. Okay. So here you can see that if you take the direction cosines of these two, it will be same because the direction is going to be the same. Only the magnitude is different, and magnitude, if you compare the two magnitude, will be exactly 5 times. The second one will be 5 times the first. Okay. So these are the two ways for vector multiplication of vector by a scalar. Next, how do we represent vector joining 2 points? Suppose we have the two position vectors are given to you. Okay. So there is one vector like this and another vector like this. Okay. So this is given in terms of, let's say, vector p equal to a1 I cap plus a2 okay. And so let us say q cap is a2 b1, sorry. So two vectors are given in terms of position vectors in this form. Okay, so what is the vector joining these 2 points? Okay, so now the question is, what is the vector joining? So this is P, and this is where Q. So now what is the vector joining these 2 points? So we already saw that using triangle law, P plus Q equal to, it will be minus R. Okay, it will be the third side of the triangle. This one is this way and this way. So this is given by actually Q minus P. Okay. So the vector joining these 2 points is given by Q minus P. So which is now B1 minus A1 into I.
Q cap or Q weight, sir?
Enama?
So cap ponna vector.
Either one, sorry, my vector cap. So vector joining the two endpoints is given by Q minus P. Okay, which is B1 minus A1 into I cap plus B2 minus A2 into J cap. k cap. Okay. So then this section formula. Section formula being then suppose the two position vectors are given. Two position vectors are given. Let's say one is a1 into I cap plus b1 a2. Let's say. Plus a3 into k cap vector. So this is your vector x. b1 into I cap. Now, so these are this is the way the 2 points are represented. Okay. So this is your point vector x vector. And this is your y vector. Now let us say we join these 2 points. Okay, so this vector is given by y minus x. We saw that. Okay, so now this vector we have to find out the position vector of a point which is going to divide this line in the ratio of m into n. Okay, so this position vector. Okay. Let us say this point is z. Okay, so this z position vector is given by n into x plus m into y by n plus m. Okay, so this gives the position vector of the point z. This is the section formula. Okay. So this we would have seen in basic algebra. So how do we divide the quantity a line in terms of in 2 ratios? So this is very similar to this. Geometry also we would have seen this similar formula. Okay. Okay. So let's do some problems now. Okay. So compute the magnitude of the following vectors. Okay. So there is a vector A which is given as I plus j plus k, I cap plus j cap plus k cap. B is given as 2 I cap minus 7 j cap minus 3 k cap. Okay. So can we solve this problem? Find the magnitude of these 2 vectors. Anybody? Okay. So I will explain. We already saw. Okay, vector is given in terms of the 3 components. Then its magnitude is equal to square root of x square plus y square plus z square.
Yes, sir.
Right. So these are the 3 components in a 1 1 1. Yeah, A had a components x y z are 1 1 1. So it is simply square root of 1 square root of 3. That's all. So similarly, compute magnitude of B.
Sir, root 32, sir.
Yeah, root of 2 square plus minus 7 square plus minus 3 square. So இப்போ எல்லாமே பாசிட்டிவ் குவாண்டிட்டி ஆயிடும் நமக்கு. 2 plus 2 square is 4, 49, 9. So add the 4, you get 4, 53, 62. That's all. Okay. Let's go to another problem. Find the scalar and vector components with the vector with initial point 2, 1 and terminal point minus 5, 7. So it is given in 2 coordinates, so you can take the third coordinate as 0. Okay. So இப்போ இதோட vector component என்ன, scalar component என்ன? So what is the scalar component? Scalar component is the magnitude. Vector component is the direction. Okay. So the question is, what is the magnitude and direction of this vector with initial point 2, 1 and terminal point is 5, 7. So what is the magnitude?
Initial point 2, 5.
Yeah. Scalar component equal to magnitude. Let us say this vector is A. So magnitude. So what is the magnitude here? Square root of yeah. 2 minus 5. The whole square, right? So the initial point is 2 and minus terminal point is 5. Put it wrongly. 1 minute.
சார் இது டிஸ்டன்ஸ் ஃபார்முலா தானே சார்?
ஆமா, 1 minute. See, here it is given, the 2 points are given, right? So what is the, we saw that, right? 1 minute. Vector joining 2 points, right? So what is the formula for vector joining 2 points? This is the formula for vector joining 2 points. So there is one vector and another vector. The vector joining 2 points is given by b1 minus a1 into I plus b2 minus a2 into j plus b3 minus a3 into k and path only. So we apply the same concept here. So since it is given, right, the vector joining these 2 points, so the vector is given by, let us say, vector joining 2 points is given by 2 minus 5 comma into I plus 1 minus 7 into j. So 2 minus 5 and then 7, right? 7i. 1 minus 7 is 6j. So this is your the vector joining these 2 points. Now, idoda scalar component na magnitude, right? So what is the magnitude? So what is the formula for that? Square root of
7 square plus 6 square minus 6 square, sir.
Yes. So that will be square root of 7 square plus minus 6 square.
$85, sir.
Square. This is your magnitude. So this is your scalar component. So what is the vector component? So how can we represent the direction of this vector? This 7i minus 6j is a vector. So the
7 by root 85, sir.
right. So we represent it in terms of the three angles, right? So represent the in terms of the angles, right? So what is cos? So we saw that L, M, and N. So here, what is L?
7 by root 85, sir.
Correct. L equal to 7 by root 85. M equal to minus 6. Right?
Minus 6 by root 85.
Minus 6 by root 85. So these represent the directions. So we can also say that this the unit vector in this direction is given by 1 by unit vector in number. This vector A, right? So unit vector in the direction of A is given by 1 by root 85 into 7i cap minus 6j cap. So this represents the direction of that vector. So we represent the unit vector in the direction. Okay. So now let's do this problem. Find the vector in the direction of phi I cap minus j cap plus 2k cap having magnitude of 8 units. So what is the magnitude of this vector? So we have to put that first. Let us say vector, this is letter A equal to phi I cap minus j cap plus 2k cap. So what is the magnitude of this? Square root of
25.
Yeah, square plus minus 1 square plus 2 square is equal to square root of 25, 26, 4, 30. Square root of 30, right? So this is your magnitude. So what is the unit vector in that direction?
Phi y cap minus j plus 2
Yeah.
divided by 30.
Simply divide it by root 30 into okay. So this is your this is a vector having magnitude is 1, right? Because it is unit vector. Now the magnitude has to be 8 units. What do we do? We know that now if it is scalar multiplication, we simply multiply all the components by that scalar, right? So that will become simply 8 by root 30 into the same thing. Phi I minus phi I cap minus j cap plus 2k cap. So this is going to have a magnitude of 8. Right? Because this A has a magnitude of root 30. So we divide it by root 30, it becomes a unit vector. Okay. So then we multiply by whatever magnitude that we require, that is 8. So then that will become a vector of having magnitude of 8 units. All of that. Okay. So let's go to another problem. Find the direction cosines of the vector given by vector A equal to I cap plus 2j cap plus 3k cap. So for that, what we should do, we have to find out the magnitude of this vector, which is again root of 1 square plus 2 square plus 3 square equal to root of 1 plus 4, 5 plus 9, 14. Therefore, direction cosines L is given by
240.
x by root of x square plus y square plus z square, right? 1 by root 14. Element, right? So you can see one important property here. If you write the three direction cosines, L square plus n square plus n square will be equal to 1. Okay. Because we computed this denominator by simply taking 1 square plus 2 square plus 3 square. So if you take L square plus n square plus n square, it will obviously it will become, you know, root of 14 divided by root of 14, which is going to be 1. So this is where these are the direction cosines of the vector, the given vector. Okay. Let's do another problem. Find the direction cosines of a vector joining these 2 points. Let us say this is point A and B. What is the vector that joins these 2 points? Is given by -1 -1. Okay. So we take the B1 minus A1 into I cap plus B2 minus A2 J cap B3 -1 minus 2 minus 2 minus 2 minus 4 1 minus 3 plus 4. So this is your vector that joins these 2 points. So now what is the magnitude of this vector? Square root of equal to 6. Okay. So now what is the direction? What are the direction cosines?
-2 divided by
L equal to -2 by 6. N equal to -4 by 6. N equal to 4 by 6. That's all. Good, this is clear. Okay, let's go to another problem. Find the sum of these 3 vectors. A is I cap minus 2 j cap plus k cap. B equal to -2 I cap plus 4 j cap plus 5 j cap. C equal to I cap minus 6 j cap minus 7 k cap. So what is A? Plus B plus C equal to, so we can simply add the components here, right? 1 minus 2 plus 1 plus minus 2 plus 4 minus 6. One plus 5 minus 7. So this becomes 0, right? 1 plus 1 minus 2, 0. So there is no I cap now. So this becomes minus 8 plus 4 minus 4 j cap. This becomes 1 plus 5, 6 minus 7 minus k cap. That's it. The sum of the three vectors is given by minus 4 j cap minus k cap. Okay. Find the position vectors of a point R which divides the line joining P1, 2, minus 1 and Q minus 1, 1, 1 in the ratio 2:1. We saw the section formula, right? So who remembers the section formula?
N into S vector plus M into Y
Yeah.
vector divided by
So it is R, right? Equal to N, which is 1 here, okay? 1 into, okay? The first one. Okay. Plus M into the second one. Divided by M plus N. That's all. So what is the net I here? 1i minus 2i is minus I. Right? 2 plus 2 minus 1 plus 2. Correct? Divided by,
yes, sir.
so that is 1 by 3 I cap minus 1 by 2 sorry, plus 4 by 3 j cap plus 1 by 3 k cap. That's it. Okay. Yeah, I think we come to the end of whatever we wanted to cover today. Okay. So what we saw today are the basic introduction to vectors. What is a vector? What is the position vector? Direction ratios or numbers. If position vector is given by A I cap plus B j cap plus C k cap. Direction ratios are simply A is to B is to C. So A, B, and C, so they are called the direction ratios or direction numbers. Okay. So what the ratio of the numbers in the three different coordinates. So adilende we derive the direction cosines, right? So that the sum of squares becomes equal to 1 or they represent the cos theta. So adukapram we saw about zero vector, unit vector, co-initial vector, co-terminal, collinear, equal and negative vectors. So then vector components I and in the three coordinates I, j and k, in addition of vectors, multiplication of vector by a scalar, vector joining 2 points in section formula to divide a line joining two position vectors, okay, in a ratio M:1, and we saw some examples. Okay. So hope these are clear. Any questions or any doubt, you can feel free to ask me now. Next class we'll continue with multiplication of vectors, vector by vector, or product of two vectors. So that's what is remaining in the vector. So okay. Okay, so let's wrap it up now then. Okay, thank you all then. Is there any question?
Thank you, sir.
Yeah. Okay.
Thank you, sir.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Yeah.
Thank you.
Thank you, sir.
Bye.